about how there's no effect. One does not affect the other. So if you think about it, parents are independent. You are their dependents, aren't you? So if they are filling out a tax form, they have to claim you as dependents on their tax forms. And it's because everything that they do, the decisions that they make, ultimately affect you. If your parent loses their job, it affects you in the sense that you are not able to buy whatever you want. Okay, if your parent gets a new job and has to move, you got to go with them. So you ultimately depend on your parent. That's how independent and dependent events work. Independent events means that there's absolutely no effect on each other. So we tend to know that independent events are things like flipping a coin and rolling a die. They have no effect on each other. Flipping a coin and flipping another coin, they have absolutely no effect on each other. Spinners have no effect on other values. Those are independent events. Dependent events is when you find the probability of something occurring the first time, and then that situation is removed. So we often see the values of do not replace, or the terms without replacement. So I want you to go ahead and write that down, that this is going to be a situation that we're dealing without replacement. I'm trying to think which colors I wanted to do. I think we're going to do independent with our pink today. And our dependent is going to be with our, no, blue. Dependent is going to be in our blue. And the terms without replacement, that's a big deal. You're picking something up and you're not putting it back into the total mix. That makes it dependent situation. So for example, there's a list of topics for a class project to choose from. If students can choose the same topic, then Taylor's choice will not affect Justin's choice. That means that they are independent. So this is going to be an independent situation. Only because students can choose the same topic. Everyone can have the same exact choice. So that means that, you know, if Ray chooses a topic, then Eob can choose the same topic. So it does, Ray's choice does not affect Eob's choice. Okay, or in this situation, Taylor's choice does not have an effect on Justin's choice. However, if a teacher decides that each student must have a different project, that each student must have a different project choice, then that makes it dependent. Because once Taylor chooses his topic first, that topic is no longer available for Justin to choose. Okay, it's kind of like, how many of you had to write book reports in elementary school? The book reports. Okay, so once you wrote a book report, could you reread the same exact book and turn that book report in for the next round? No, you read the book already. So you cannot use that book again. So the likelihood of what you're going to choose next changes. Okay? So it ultimately, dependent events have an effect on the total. Let's write that down too. Dependent events have an effect on the total number of outcomes. Your dependent events are going to have an effect on whatever the total number of outcomes are. So every time you go to the next round of activity, the total keeps getting smaller and smaller because you're removing something each time. Okay, so what I want you guys to do is go through these 4 scenarios and identify them as whether they are independent situations or dependent situations. Are they independent or dependent? Go ahead and take a couple minutes to do that. All right, let's take a look. Erica rolls a 3 on a number cube and then a 2 on another number cube. Is that independent or dependent? Independent, right? It has no effect on each other. So this is going to be considered to be independent. All right. What about B? Tommy chooses a 7th grader for his team from a group of 7th and 8th graders. And then Juan chooses a different 7th grader from the remaining students. Independent or dependent? Dependent, right? Once Tommy chooses a 7th grader, that 7th grader is no longer available for Juan's team. Okay, so that's a dependent situation. All right, Yuki chooses a red marble from a bag and then doesn't replace it. She then draws a green marble. Independent or dependent? Dependent. Right? The key term, the fact that it says that she does not replace it, doesn't get replaced, that's a big deal. Without replacement, it's going to cause it to be a dependent situation. All right, Kathy draws a 4 from a set of cards numbered 1 through 10, and then rolls a 2 on a number cube. What is that? Independent. Has no effect on each other. Okay, drawing a card, and then rolling the number cube has absolutely no effect. All right, let's go on to the next page. All right, on the back, we're going to be talking about how to solve for probability of independent events. So probability of independent events, like we've already done before with compound probabilities, we know that we multiply. We know that we're doing multiplication. So if you see the word and, it means that you're doing this and you want the other event to happen as well. That means that you have 2 separate activities that you're trying to find the probability for. So you multiply those probabilities. These are independent probabilities here because we're rolling a die, we're rolling the die and flipping a coin. They have no effect on each other whatsoever. So we can separate them out and solve for them each independently. So that means that we're going to take the probability of event A happening, and then we're going to multiply it. Do our lovely little multiplication. We're going to multiply it by the probability that event B is going to happen. So we're just separating them out into 2 separate events or 2 separate probabilities, which we've already been doing with our compound events. So for here, probability that the coin is going to land on heads. What is the probability that a coin will land on heads? 1/2. All right, these should be very, very quick returns of comments. Okay, then we've got the probability that it's going to land on the number 6. We're going to roll the die and land on the number 6. What is that? 1/6. What do you think is the biggest mistake people accidentally make when they're like, oh, I'm rolling a 6 and my probability is, what do you think, Maya Isabel? Okay, there's a possibility that it might not simplify, but in this case, 1/6 doesn't have to be simplified. What else do you think might be, Ray? Okay, maybe they put 36 because maybe they're thinking it's 2 die. Yeah, that's the most common mistake. So Armando said that they put 6/6. I can't tell you how many times I see it where people are like, oh, the probability of rolling a 2 is 2 out of 6 because they took the desired outcome instead of looking at how often the outcome occurs. So that is the biggest mistake that I've seen. So be very, very careful because it's not just, you could be the smartest person in the world and you still make the same mistakes, okay? So be very careful about that. All right, once we have the 2 probabilities, we're going to go ahead and multiply them. And then 1/2 times 1/6 is just going to come out to 1/12. We're going to go ahead and just work with fractions today because I think you guys at this point know how to convert. So I'm not worried about your conversions. We're just going to simplify it to fractions. All right. Probability that the coin's going to land on tails. Probability that the coin's going to land on tails is 1/2. Okay, and then the probability that we're going to get a number that is less than 3, a value less than 3. How many numbers are less than 3 on the number cube? 2. Okay, 2 out of 6. So then we'll go ahead and multiply those. 1/2 times 2/6 comes out to 1/6. Okay, go ahead and do C and D on your own. C and D are on your own. So probability of tails and a value that is greater than 1. Probability of tails and a value greater than 1. What did you get? Let's go with Andy. Andy, why don't you tell me what you got for C? Andy? Okay, well, tell me what the probability of tails is, honey. 1/2, okay. And what's the probability of getting a number that's greater than 1? Greater than 1. So which numbers on the number cube are greater than 1? Okay, and 6. So how many numbers is that? 5 numbers out of 6. So then multiply those together. So do 1/2 times 5, 6. What do you get? Five over 12. There you go. Okay. Problem D, the probability of heads and a prime number. Paris, what did you get? 1/4. Very good. So probability that it's going to land on heads is 1/2. Probability that you're going to get a prime number. Remember, the prime numbers are 2, 3, and 5 on the number cube. So that's 3 out of 6. You'll multiply those together, and it comes out to 1/4. Okay, I have some space down here below if you would like for me to go over another example of independent, but we've kind of done a lot of independent probabilities. Raise your hand if you need me to do another example. No? Okay, I'm more concerned about the dependent. So let's go ahead and move on to dependent. So for dependent probability, like I said, once you are working through the problem, your probability of the first event is just normal, right? You find it just like normal. But then the probability that the second event happens, it's after you have removed the first event. After you've taken away the first outcome that happened, it's no longer available anymore. It changes what the probability is going to be because the total changes, right? So here, Micah has 5 $1 bills. Okay, so a dollar bill, that's money. 5 $1 bills. She's got 3 $10 bills, and she's got 2 $20 bills. She picks 2 bills at random and wants to know what is the probability that both bills are going to be 20s, that she's going to pick the $20 bill both times in a row. Okay, so what you're going to do here, guys, the best thing I can tell you is to set it up like a map. When you're trying to find the probability that the first event is going to happen, and then the probability that the second event happens after the first event has been removed, if you map the situation out, it makes it easier for you to see exactly what you've got. Okay, so let's start with round A. In round A, she currently has $1 bills. She's got 5 of them. For her $10 bills, she's got 3 of them. And for her $20 bills, she's got 2 of them. Right? And that's a total of 10 bills that she's got. She has a total of 10 actual bills between the ones, the 5, or the ones, the 10s, and the 20s. She's got a total of 10 bills. So the probability that the first bill is going to be a 20. The probability that the first bill is going to be a 20 is she's got 2 of them out of 10 total. So it's 2/10. Does everybody follow that part so far? Right? She's got 2 $20 bills out of 10 total bills that she's got in her wallet. Now, she's not going to get that bill back. So the amount of $20 bills has decreased to what? To 1. She took one of the $20 bills away. She took one of the $20 bills away. So when we're doing activity B, she subtracted one of those $20 bills away, and it changed to a 1. She still has 5 $1 bills. She still has 3 $10 bills, but she's now down to 1 $20 bill. And what is her new total? 9 bills. She now has only 9 bills left to choose from. And I want the probability that she's going to choose the $20 bill again. So how many $20 bills are left for round B? 1 out of how many? 9. That's how dependent events work. Your total changes. Sometimes your numerator's value will change as well, depending on what outcome you're looking for. See, in this case, we wanted both of them to be 20s, so we knew that the probability of 20 itself was always going to be changing. Sometimes, though, maybe I might have done probability of 20 and then a probability of a 1. Well, then the 5 never changed, but the total is always going to change. The total will always decrease by 1. Okay? All right. So we have 2 over 10 and then 1 over 9. We're going to multiply those together and it comes out to 1 over 45. Right? 2 over 90 simplifies to 1 over 45. Okay, let's take a look again at the next problem. Hey, I talked to you guys about it before, book reports, right? If you're doing a book report, once you read the book, you can't use that same book again. So we've got a reading list with 5 historical books and 3 science fiction books. Yeah, 5 historical and 3 sci-fi. We want the probability that Josh is going to randomly choose a historical book for his first book report and then a sci-fi book for his second book report. So with our very first round for event A, before we even start, we've got a listing of historical books, which is 5. And then we've got the sci-fi books, which he's got 3. How many total books does he have to choose from? 8, right? 5 plus 3 is equal to 8. So for event A, the probability that he's going to choose a historical book, how many historical books does he have? 5 out of how many total books? 8. So that probability is easy to find. You didn't have to do anything. You don't have to take anything away. It's just as it is. Plain and simple, right in front of you. It's not until the second round when we're like, okay, hey, he read that historical book. He can't read that book again or do a book report on it again. He could read it again, but he can't do a report on it again. So that means this book is being taken away, and we're now left with how many historical books? 4. Did the sci-fi number change? No. Okay, he didn't do a report on any sci-fi books yet. So the sci-fi number still stays the same. Did the total change? Yes. The total now has decreased to 7, right? 4 plus 3 is 7. Okay, then we're going to do the probability that he's going to choose a sci-fi book. How many science fiction books are there? 3 out of how many total left? 7. So we're going to do 5 over 8 times 3 over 7. 5 over 8 times 3 over 7. And that's going to come out to 15 over 56. When you're talking about dependent events, the dependent situation is always ultimately going to have a change in the total. Do you guys want another practice problem on it? Yeah? Okay. That one I assume. You guys have been doing independent for a little while. Dependent, this is still kind of roughly new. So I gave some space down here. Let's do something like, okay, we're going to eat some fruit. Okay, so this will be problem C. All right, we have a fruit basket. The fruit basket has 7 bananas. And it's got 5 apples. And it's got 8 kiwis. All right, fruit basket has 7 bananas, 5 apples, and 8 kiwis. So I want the probability. I want the probability that I first eat, we'll say a kiwi, and then I'm going to eat an apple. I want to first eat the kiwi, and then I want to eat an apple. So if I'm eating it, is it going to get replaced? No. Okay, once you've eaten it, it's gone. It's not replaced there anymore. I want you guys to try this one on your own. Okay? 7 bananas, 5 apples, 8 kiwis. I'm going to eat a kiwi first, and then I'm going to eat an apple. You don't understand it? Okay, so do you have your Google Translate? Right, you can open up your computer and do Google Translate to understand. Okay? All right, let's go ahead and take a look at this one. So when we are mapping it out for our first activity, the first thing I want to notice is, okay, I have, for bananas, I've got 7. For apples, I've got 5. And for kiwis, I have 8, which means I have a total of 20 fruit. So the probability that I'm going to first eat a kiwi, is going to be 8 out of 20. Okay, so if I eat the kiwi becomes 7 kiwis left, which means I now have a total of 19 fruit because my bananas still stayed 7 and my apples still stayed 5. So for activity B, I have 7 kiwis, 5 apples, and 7 bananas. I want the probability that I'm going to eat an apple. That's going to be 5 out of 19. And then I'm just going to multiply those straight across. And that's going to become 2 out of 19. 2 out of 19. Okay, I want to do one more based off of the same examples, based off the same problem. But I want the probability this time that I'm going to choose 2 fruits to eat that are not apples. I want to choose 2 fruits that are not apples. Okay, so if I start the problem all over again, I'm going to do this one with you guys because this one you have a question similar to it on your assignment tonight. when I start this question over, okay, I start with the 7 bananas. I start with the 5 apples. I start with the 8 kiwi for a total of 20 fruits. And I want the probability right now that I am not going to choose an apple. So based off of this situation, and I choose to not have an apple, how many fruits up here are not apples? 15, right? 7 plus 8. 7 plus 8. That's, I can have a banana or I can have a kiwi. Either one of those are considered to not be apples. So that's going to be 15 out of 20. Now, I only ate one fruit. Does it matter if I ate a banana or a kiwi? No, doesn't matter. I'm just going to take it away from one of them. It does not matter which one I take it away from. So I'm just going to go ahead and take it away from bananas. I'm going to pretend I ate a banana, got myself some potassium, and I now have 6 bananas left. I still have 5 apples. I still have 8 kiwis, but I'm now down to 19 fruits. And again, I want the probability that I am not going to have an apple. I do not want to have an apple again. How many fruits are left that are not apples? 14 out of 19. And then we're going to go ahead and multiply. Okay, so we'll do 15 over 20 times 14 over 19, and we get 21 over 38. Okay, so this is the area that causes the most concern, is those dependent probabilities. On your assignment for tonight, or for today, you get 20 minutes in class time to be able to work on it. You've got an entire front page, 12 questions that are only on independent probability. This entire front page is just independent, those 12 questions. On the back, these ones are all dependent because they all say not replaced. Okay, you are not going to replace them. So this is the one that's probably going to cause the most concern. So if I were you, which side would I do first while you're sitting in class? The hard one. Why should you do the hard one while you're sitting in class? So you can ask me questions. Okay? You are welcome to work with up to 2 people, like you and 2 other people. So you can have 3 people in a group to work with. I'm perfectly fine if you would like to do that. Just make sure you are actually working. Okay? Go ahead and get started.